So here's the question then, part A and part B. Let's have a look at it here. I've summarized it here. First of all, this one here. The double angle formula, first of all, part A. So let's just remind ourselves of that. Cosine 2 theta is equal to cosine squared theta minus sine squared. And when we replace the sine squared, we see that it's going to be 2 cos squared minus 1, isn't it? And we need that in here because we've got cos squared and cos, and we can have a quadratic. So here then, let's put it in. 8 lots of this plus 6 is equal to cos squared plus cos. So let's see what we get. So we get 16 cos squareds coming out here when we expand the bracket. Minus the 8 plus 6 equals cosine squared theta plus cos theta. So just expanded the bracket then. Move this over to be minus 1, so that leaves 15 cosine squared theta. Then move the cos over, minus cosine theta. Minus 8 plus 6 is minus 2. There's nothing left on this side, so we move that over to be minus 1 to make 15. The cos came over as well to make minus cos, and there's minus 2 here, nothing left on that side. So we've got a quadratic then, haven't we? So it's got to be 2 and 1, and it looks like 5 and 3 because 3 2s are 6 and 5 1s are 5. The 6 is bigger than the 5, so that's minus and that's a plus. That's the guess. Let's just check it. 15 cos squared minus 6 plus 5 is the minus 1, and plus times minus is a minus. 2 1s are 2. So that looks good. So that tells us here cosine theta is equal to, needs to be minus 1/3. This one, cosine theta, needs to be 2/5, doesn't it? So these are the two possible solutions. So let's look at this one then first of all. Draw a circle, right cast. Okay, cosine is negative, cosine positive here and here, so it's negative there and there. Draw 2 lines, mark off alpha, the associated acute angle, and write down cos alpha and drop the negative, if there is one to drop. Shift cos of 1/3, we're working in degrees, so let's do that then. We're in degrees, shift cos of 1/3. We'll do it nice and accurate. 1.230. 1.230. Let's go back to that. That can't be right. That must read radians. My eyes must need to test in degrees. And that's 70.528. 70.528 degrees. Okay, there's alpha. So theta then will equal, well, the first one will be around to here, 180 minus this, which is 109.471 degrees. And the other solution here, well, we go around 180 and then add another 70 this, so it's 250, isn't it? 0.528 degrees. Okay, so there's our solution there for the first one. Now let's do the second one then. Draw the circle, CAST. Cosine is positive here and here. Draw 2 lines, mark off alpha, the associated acute angle, and write cosine alpha is equal to 2/5 or 0.4. So shift cos 0.4. Shift cos 0.4. 2/5. 66.421. 421 degrees. So what do we got? We got theta is equal to, the first solution will be here, 66.421 degrees, and the other solution is right round to here, 360 back this much. So it's 290, 280, isn't it? 283. 0.578 degrees. So our final answer then, let's do it to 2dp, 109.47 degrees, 250, 0.53 degrees, 66.42 degrees, and 283.58 degrees. And that was the 2 decimal places. Okay, just one slight correction here. I've just noticed it when I had a look. 360 takes 66, 290. I should have done it on the calculator probably, shouldn't I? 293. So sorry about that. So that's a 9-3 there. Easy mistake for me to make apparently. 293.58, there we go. Because 9 and 6 is 15 and we want 360, so that's right. Okay. So that's part A then. Now we do part B. I'm going to move this down and have a look at part B now. So let's take part B and let's have a look at it down the page. Okay, put it in here. Let's have a go at it. Right, so express this as what? Express this as this. Okay, so part B, here, root 15 cosine theta minus sine theta is equal to this, cos minus sine, isn't it? R cosine theta cosine alpha minus R sine theta sine alpha. So what have we got then? The cos, R cos alpha and R sine alpha. R sine alpha is minus 1, isn't it? And R cosine alpha must equal the root 15, mustn't it? Just equating the sines and the cosines on this line. So that tells us what tan alpha is then. Divide 1 by 2. 1 by 2 on this side, the r's cancel, sine over cos, is equal to minus 1 over root 15. So that tells us what alpha is. It's acute, so we can do that straight away. Shift tan minus 1 divided by root 15. A bit worried about this. Root 15 close bracket. Yeah, minus 14 degrees. Okay, minus 1 plus here. So let's look back at the question. Alpha's acute. Oh, silly me. R cos plus is a minus, isn't it? That. So R sine alpha would, the minus goes with the minus to be plus 1. So it's plus root 15. So that tells us then, let's get rid of the minus. Equals 14.477. 14.477. So I just rushed the correspondence here. R sine alpha will be the same as this value of sine theta, which is minus 1. And there's a minus there. So we can drop it both sides. And the R cos alpha was root 15. So that tells us alpha. Now if we square this and square this, we get R squared, don't we? R squared is equal to this squared plus this squared. That's 16, so R is equal to 4, so R is positive. So, okay, so here, what have we got then? So we want to solve this equation, which we've got above, equals 3. So here, R, 4, cosine theta plus alpha 14.477 is equal to 3. Okay, good. So let's solve this equation then. So that tells us that cosine theta plus the 14.477 is equal to, move the 4 from times to divide, 3/4 is positive. CAST, cos is positive here and here. Draw two lines, mark off alpha, the associated acute angle, and simply write cos alpha is equal to 3/4. Shift cos of 3/4 then. Cos of 0.75 equals 41.409, 41.409 ... Okay, so that's alpha. So that tells us that theta plus 14.477 equals, the first solution would be around to here, 41.409, or theta plus the 14.477 equals, and then the other solution round to here, which is 360 minus 41, so that's 318.590. Okay, that's what we've got there then. So that tells us what theta is. They're both in range, which is good, so we don't have to tweak any of the ranges because this value is smaller than the 41. So it didn't create any additional problems at all. Because the theta's from 0 to 360 in this question, isn't it? Up the top here. So that's fine, everything's okay. So theta is equal to then, so it's going to be 41.409, which is in the calculator, minus 14.477, which is 26.93. 26.93, and that's now rounded to 2 degrees. And the other one, 318.590 minus 14.477, 304.11, and there's to 2dp, 304.11, and they're both to 2dp. And there's our two solutions.